Positron AI is building purpose-built inference hardware to challenge NVIDIA's dominance, and doing it with a team of just 70 people. Today, we're talking with Mitesh Agrawal, CEO, about the market opportunity, the technology, and what it actually takes to earn customer trust in a market NVIDIA owns.
First and foremost, it always comes down to people relationships, right? So I knew Positron's leadership team, Thomas Sohmers, Edward, Bernie, Greg, all of the leadership team here and all of the founding team here, more importantly. And what their vision was in building Positron AI from first principles, really around silicon for inference, really maximizing memory technologies. While I was at Lambda, obviously saw the inflection into the inference market, where inference started to really outpace spend over training compute. And in inference, primarily, the bottlenecks are around memory bandwidth and memory capacity. So knew that there is a potential chance for a company like a Positron AI to really grab market share. I think first and foremost, I do want to say the second, NVIDIA is one of the smartest companies on the planet, and they'll continue to not only grow massively, but in fact, they'll probably even drive their market share more and more for the inference side of things. It's the fact that, you have to figure out how to not only coexist in the world of NVIDIA, but then also find certain specific paths of how to innovate that, they're not as focused on. And so for us, that's been really around the memory story of ours. And, we are launching with a product that is almost a magnitude 10 times more memory capacity than NVIDIA's product. And that really attracted me from a technological perspective. But then also as I said, my experience at Lambda scale, as I said, NVIDIA is still the best silicon that is out there. Knowing where the market is going and thought that this would be a great opportunity for me to go into the underlying technology stack. Lambda is a brilliant company built on top of kind of infrastructure, silicon technology, and AI models and data. It'll be awesome to go underneath that layer and then go into the silicon technology myself and really work closely with the team that I really admire, that I've known for a long time. So that really led to me joining Positron AI 18 months into the company's journey. And so I've been now here almost 18 months, and it's been a really phenomenal learning curve for me. And we are trying to really grow, as quickly as we can.
From Lambda's GPU cloud to Positron Silicon, a deliberate move to where the bottleneck actually lives. But how big is the problem Positron is solving?
NVIDIA is the most important and the largest player. The market size is also so large that, if you can solve one niche, one part of it, two parts of it, then it's a big market to start from, to grow into. Just to kind of give some quantitative numbers, right? I think I was reading that there's been over $250 billion worth of hardware capex. So on compute spent for inference in 2026, or will be spent in 2026. And that number is estimated to at least go up to over $750 billion by 2030. So, as it comes from a market sizing perspective, I doubt there are any bigger markets than the silicon and overall infrastructure market out there. And this is kind of the critical aspect, right? I think you mentioned how the applications are really expanding to everyday users, which means that each application is so massive. There's so much kind of both market sizing in terms of people using it. There's such large kind of use cases that are popping up that obviously even for NVIDIA, for a single chip to do them all is not as straightforward, and to do it super well, that's where you can find really your kind of niches of driving that efficiency. And for Positron AI, that's kind of where we are growing into, with our memory capacity, our focus in the largest models. Obviously the model that is making all the news right now is Anthropic Fable and Mythos. These are almost closer to 10 trillion parameter models, right? So model sizes are getting larger, but also more importantly, you look at the amount of, for example, in coding application, the amount of caches that are getting really, really exploding. I think, that's where, having a huge amount of memory capacity is really helpful. And then decode-heavy applications, whether it's autoregressive video generation and others, are becoming popular as well. So that's where we are trended towards from our perspective, and that's the market. And each of these applications are driving, and if you look at it from a revenue perspective, tens of billions of dollars of revenue, especially in the coding side, and others are coming up. So, if you can become a really, really good technology, especially from a silicon semiconductor side of things, then you can get a decent part of the market and really drive revenue growth here, right? And I think it speaks to us to kind of the market sizing as well, where Positron, we are only a 3-year-old company. We launched our first product within 2 years of founding the company, and that product already is generating massive amounts of revenue for us this year itself, right? So that speaks to the market question as well that you asked around how big the market is. It's like, for us, it almost feels like infinite because we have a long runway to going. Obviously, NVIDIA is already over almost 300 billion annualized revenue run rate, right? And I think so we have a long way to catch up there, but that is the ambition. I think it's kind of, we can one day reach those levels of revenue and chip deployments and chip sales.
From $250 billion in inference capex today to over $750 billion by 2030, and Positron sitting at the intersection of memory capacity and model scale. But how does a 3-year-old company earn trust in a market NVIDIA has owned for years?
NVIDIA is not only the default choice, but it's the best choice for a lot of the workloads out there, right? So it's default because it's also one of the best. I think where Positron is focused on is the memory side of the story, and this is where for the applications that are memory bound, so some of the inference applications and some of the decode-heavy applications, that's where we will be standing on, and that's where we will try and outperform NVIDIA from performance per dollar perspective, raw performance perspective, performance per power. Energy is obviously a big bottleneck in the industry, right? So how can it drive more efficiency? That's kind of where that comes into, and Positron's fundamental focus is how do we drive maximum memory bandwidth utilization, so really driving fast kind of data flow, and then how to drive huge amounts of memory capacity. So for example, Positron's second generation architecture is going to come out with 2.3 terabytes of memory capacity per chip. Compared to that to NVIDIA Rubin, it starts with 288 gigabytes, right? So obviously 1/9 the memory capacity there, right? So that's one of the key ways that we see to drive innovation and then drive a market segment where, okay, NVIDIA can obviously perform in that market segment, but we can drive much more efficient performance, much higher performances in that segment, right? And that's kind of where how we you crawl, walk, run, right? You find your mission and tier, and then and you really go into it. And then to your point, how do you make the market trust you? And I think NVIDIA has given the right answer, and Jensen always says this. Obviously there's different modes for NVIDIA, CUDA, and other things. But the biggest mode NVIDIA has, that is they come out with a product or a product cycle every year and a half or a year right now, right? So, and people trust that they will come out with the next product, which will be better and which will be better and which will be better. And I think this is very critical. I think a lot of silicon companies take too long to come out with new products. And for us, one of the key things that drives us is product cadence. How can we quickly come up with a generation of product right now we are doing it every 2 years. We want to match NVIDIA and come out with a product every 15 to 18 months. And that's how you drive confidence as well. It's like, if people know that you're going to come out with a new product every 15, 18 months, they can start trusting you and placing orders for your product ahead of time because they know that you've already delivered. Your history shows that you've delivered 3, 4, 5 product generations. And I think that's kind of how we intend to really drive confidence in the market around it. And then the last thing I'll say here is that it's not just always performance comparison against NVIDIA or the major other major players like TPUs or Trainium or AMD. It's also about the fact that can you, in the world of supply chain constraint and power constraint, can you actually practically manufacture your chip, and can you actually get it deployed? I think this is the key component part of it, which is that you can design a wonderful chip, but if it uses the same supply chain components as NVIDIA does and same power setup that NVIDIA does, then good luck getting those components ahead of NVIDIA and TPU and Microsoft and Google and Broadcom and AMD, right? It's not really, that's the other mode of NVIDIA, is like they have the supply chain completely figured out, and they've been the smartest about this, right? So it's really important that not only do you drive technical innovation, but you drive innovation around the supply chain scarcities and around the power scarcities of the world. So for us, we are air cooled by default. We can also do liquid cooling, but by being air cooled by default, it means that we go into data centers that NVIDIA deployments are not going into. So it allows you to carve out power in the current power constrained world. We're not using the same memory technologies NVIDIA is. So we're not in the same line as NVIDIA and Google and AMDs of the world, right? So we're using something else. So that allows you to get allocations for those. So it's very, very critical alongside technical innovation that you drive innovation around the physical constraints of manufacturing.
A next-generation chip with 10 times more memory than NVIDIA, air-cooled by default, and a supply chain built to avoid NVIDIA's bottlenecks. With $230 million in the bank, where does the focus go first?
Fundamentally, we are a technology R&D company, right? So, first and foremost, proof is always in the pudding. So we always have to come out with products that work and that work very well, that the market is interested in from a cost of ownership perspective, from performance perspective, right? So I think, especially you brought up the funding, like if you were to ask, like the other way to ask that question is like, how best do you use your funds, right? Like, what is kind of the allocation? I think the biggest allocation goes towards product R&D and build out, right? For a silicon company, we have to do tape out. So we have non-recurring expense or CapEx expense around all of the things that go into a tape out process for silicon, all the way from getting mask sets from TSMC to IP licenses to backend design and all other things. And these are big, chunky, expensive categories, right? So that's kind of our primary expense. Obviously, you can't build a silicon company without amazing talent, and the talent in this space has to be really, really good to stand out, to do technical innovation. We're very proud that our talent is not only great, but we have achieved a lot with a very small group of team. We are still only 70 plus people to this date as of today, and having already gotten a product out, getting our second generation product out pretty soon. With a small team, we're very proud of it, but also, like, you can imagine the talent density, and as such, you need to spend on getting the talent density, and rightly so, well deserved from kind of our talent pool perspective. So that's kind of second part of it. And then I will say that lastly, while you almost use the funding or cash as a strategic asset, right? In the supply constrained world, you want to get allocation for certain components, and you're more likely to get that allocation if you have cash on the balance sheet. From that perspective, and so it's very important that you have really good balance sheet to drive supply chain robustness, and also from a customer believing you, right? If a customer wants to place a big order, they need to believe that you can actually get allocation and order it, right? I think that's kind of where the fundraising really helps from our perspective. But yeah, it's always first and foremost is drive product, because if the product is good, then you can figure out the rest of the structures post that. And to drive a good product, you need a great team.
Product first, talent second, supply chain third, and 70 people already delivering 2 product generations. So what kind of culture does it take to move that fast?
We tend to keep it simple. I mean, for us, pretty much execution is the culture. I think, like, for us, we're not dogmatic about any one particular thing, whether that's like in office versus remote, or whether that's from a culture perspective. We have a hot pot of people that come from different backgrounds, from a technical perspective, come from different ways of thinking. Obviously, people that have worked at very large companies and driven amazing certain progress, people that have worked and had their own startups a lot. So we're not dogmatic about it. We're very, very like open, and we try to get the best qualities, hopefully, and really have people contribute in their best kind of way. But yeah, really it comes down to execution. I think if you're responsible for tasks and timelines and you deliver on it, I think the way, whether you do it with a single-minded kind of focus on that, or whether you like to have a much more democratic process of discussing with the team members, that's left up to you. As you're not blocking your other colleagues, and you're delivering on the things that you need to, and things like those. So I mean, for us, as I said, we just try to keep it simple. Execution is the culture, and for a small team, I think that's the motivating factor. Like, most people join us because they want to have their name on building something unique, something that drives the compute of the future, and something that obviously gives them a lot of pleasure in terms of utilizing their intellectual knowledge and curiosity to drive a new product and get that product out quickly. This is why product cadence matters, because if you're like thinking about something and you're trying to drive something and that product just never comes to fruition, it just never exists, it takes 4, 5, 6 years, then people get, they get sad, or they demotivated, or things like those, right? This is why we want to also drive like really fast product cadence, because we want, when people come up with ideas, they want to get executed quickly, And if it's not feasible in the current generation product, because there's another product coming right behind it, you can put that idea into that product, right? So this becomes a very motivating kind of factor for a lot of folks. Obviously, it means that you need to have good mature processes in terms of churning out products, year in, year out. But from a team perspective, we really just care about right now is about how do we execute, how do we get products out, how do we drive revenue into the company. I say this to everyone. Everyone is a salesperson in the way of you're constantly thinking about how can I make this product better? How can I make this more useful for customers? And so it's very important that, people follow the market, people understand what the use cases are and so on. But rightly so, majority of our company, over, I would say 85-90% of our company is engineering. So they're really just focused on execution of different principles of engineering that go into silicon and system build out.
70 people, 2 product generations, and a market growing from hundreds of billions to nearly $1 trillion. Positron AI isn't waiting for NVIDIA to slow down. It's building where NVIDIA isn't looking.